Good morning, everybody. I am Maguni Mahakhud. So, in this class, we will learn about combinatorics. So, any one of you have been introduced to these things or not? Yeah. And you. So, those who have not introduced, don't worry. It's not very difficult subject, but it involves only addition, multiplication, those things. But you have to have some logic on behind it. So, we will start by giving some examples, and from those examples we will generalize some principles, and using those principles we will do some problems. So, first I will give one example. Suppose you have to go from Chennai to Simla via Delhi, and you are here Chennai, you have to go Simla via Delhi. So, you are going by train only. So, there are 3 trains from Chennai to Delhi named A, B, C. A, B, C. You can choose one of them, right? So, from Delhi to Simla, there are 2 trains named R and S. So, how many ways can you complete your journey?
6
ways.
6 ways.
6 ways. How do you know?
Sir,
So it's like you can choose A, B, C, sir. You have 3 starting roads,
Okay.
and with A, B, C each, you have 2 different options R and S. So with A you have 2, with B you have 2. With C
So,
you have
other people followed what he said?
Yes.
What?
Yeah.
So, if you go by train A, so this is train A. So, we come to Delhi. So, here we have how many choices to go to? Two choices. If you start from train A to Delhi, from Chennai to Delhi, then to reach Simla, we have 2 choices, right? In RS to go to Simla. So, if we go by B also, so we have 2 choices, right? By C, if you go, we have 2 choices. So, 2, 2, 2. So, how many ways total? 6 ways, right? Okay. So, we can write the number of ways for completing the journey is, suppose we tell this tax 1 or T1. First we have to go from Chennai to Delhi. So, how many ways? 3 ways. So, first tax is T1 in how many ways? 3 ways. So, 3 into, and the second tax is going from Delhi to Simla. There are 2 ways. So, we just multiply by 2, we will get 6, right? Okay. So, take another example. Suppose you in a class, there are in a class there are 10 boys and 8 girls, and the teacher has to choose 1 boy and 1 girl. The teacher has to choose 1 boy or and one gull. So how many ways he can do it?
80.
How how many ways? 80. Okay, how do you know? Like the same way, right?
Yeah.
If we choose
One boy.
first
and
boy,
then
then there are 8
Yeah,
choices.
so the one boy, 8 girls, and 10 boys. So you
Right.
multiply.
Okay. So the number of ways will be is equal to 10 into 8 equal to 80. Right. Okay. So in this order, if you have suppose here first choice, first task was to T1, this was T2. First task was choosing one boy, the second task was choosing
Yeah, 8 girls.
girl. So first task was can be done in 10 ways, second task can be done in 8 ways. So total 8 into 10 into 8 equal to 80 ways. So can you generalize if we have T1, T2 like k number of tasks, and each task can be done in M1, M2 like this 10, 8, M1, M2, M3 up to Mk ways. So how many ways can we do that task? Okay. So we'll write this here. That is called fundamental principles of counting. Of counting. Okay. So what is the statement? If we have, suppose we have T1 k number of tasks, k number of tasks, T1 comma T2 comma dot 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 Tk, and T1 can be done in M1 ways, T2 can be done M2 ways, and dot 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 Tk can be done in Mk ways. Then if we have to do all the tasks T1 to Tk, T1, T2 dot 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 Tk, then the number of ways we can do is the number of ways we can do is M1 plus M2 plus M3 plus dot 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 plus Mk, right? Okay. So based on this principle we will do one example. So if you have to do one 4-digit number, how many different 4 digits can be numbers are 4-digit numbers are there. Are there? One that are odd. That are odd first. Second, that are odd and larger than 500, 5,000, sorry, since 4-digit we are taking, that are only odd digits. And fourth, that are only even digits.
Should the digits be distinct?
Sorry?
Should the digits be distinct?
Yeah, so digits, how many digits we have?
4 digits.
We have to make about 4 digits number, but there are how many digits? 0 to 9. We have to use 0 to 9. So there are, we have to use 0, 1 up to 9, right? How many are there? 10. Sorry?
Is repetition allowed? It's like 3,333.
Yeah. Repetition is allowed. All kinds of things are allowed. So first one, how many ways the first one can be done?
3, 6, 4.
So we have actually, to make one 4-digit numbers, we have unit place, then 10th place, then
4,500.
100th place, then 1000th place. So first we have to make 4-digit numbers that are odd. Odd means in the unit place what should it contain? 1, 3, 4. 1, 3, 5, 7. Right. So how many ways? 5 ways. Right. So first problem can be done. So here we have. So we can assume that this is task 1, this is task 2, this is task 3, this is task 4, right? So we have to fill up this task to make one 4-digit numbers. So the first task can be done in 5 ways, right? And the second, that can be any, right? 10 ways. And this one, 10 ways. And this one, why not 10? 0. If you put 0, then it will be 3-digit number, not 4. Okay. So you have 9.
Yeah.
So what number you get? Okay, you can calculate. Okay. Just okay, 4,500, right? Okay. So
2,500, sir.
okay, 2,000. How?
So next one, sir.
Oh, next one. Okay. So that are odd and larger than 5,000. So second problem, how many ways we can do? So similarly, that are only, that are odd and larger than 500. Odd, so a unit place can be
5.
5 ways we can fill up. And 10th place,
10 ways.
10 ways, right? 100th place,
10 ways. 10. Next step.
10 ways.
5 ways.
And 1000th place, 5 ways. 5 ways. How many ways?
5, sir. 5, sir. 5.
What? 5, 6, 7, 8, 9. How many? Since the number should be greater than 5,000. Sorry?
Even 5,000.
No, if so, this is also no, larger than 5,000. Huh? Yeah. This number, we can construct this number, na? So this is greater than 5,000. Okay. So we should include also 5, right? So how many ways we can include? 5 ways. Yeah. So how much it was now? 2,500, right? But if you make that even digit, so one catch. So if we instead of that are odd and larger than 5,000, if we make it that are even and larger than 5,000,
4,999.
what will be the case?
2,499.
What will be the case? If these are even and larger than 5,000.
5,000 is
So,
more.
so there are 5 even also. How many even numbers?
Only one should be
One should,
excluded.
that is
5,000 should be 5,000 should
Yeah.
be
So 2,499.
Yeah.
Sorry. Now, if there are even, so unit place, how many ways we can
ways.
replace?
5 ways.
5 ways, right? This is also 10 ways. This is 10 ways. This is 5 ways, but minus 1. Why?
Because it is excluded.
One number will come 5,000, but we are telling that this is larger than 5,000. So that number we should exclude, right? If we one will ask larger than or equal to, then we will include that one. Understood? Okay. So then that third one, that are only odd digits. So this can be 5, 5, 5, 5, 625, right? The second, last one also?
500, 500, 500, 500, 500, 500.
So for even that are only even digits. So unit place can be
4.
Hey, unit is 0.
unit place. 5 ways, right? 10 place 5 and 100 place 5 and this one
Because 0 can't come.
yeah 4. So how many ways?
500.
500. So did you clear this? Are you clear this principle and where you can use this one? Okay. In the end, actually, I will give one problem practice set. So if you have time, we can do. Okay. Now, let's do some more examples, right? 1, 2, this is suppose 3. Suppose in the previous, like in the previous question, in the class there were 10 boys and 8 girls, right? So now if the teacher has to, now the teacher has to select or to choose one boy or one girl. So how many ways you can?
18.
18.
Hmm?
18.
18.
18. How did you know?
10 plus 8.
Add them and
10 plus 8.
one of them is
So there we were multiplying. Here we are adding. Why?
Only one is selected.
Or what is the difference between? Because there we have to do all the tasks T1, T2, T3, T4 up to Tk. Here, if we call this one T1, this one T2, we have to do only T1 or T2, right? So there, since we are doing all the tasks there, we have to multiply everything. But here, since we are doing one of them, so we have to add them, right? So number of ways is equal to 10 plus 8 equal to 18. Okay. Now one more example. So do you know everyone familiar with playing cards? Yeah. Okay. So suppose we have a standard deck of playing cards, and we have to from a standard deck of playing cards. Standard means it has 52 cards and 4 suites, and each has 13 numbers. Okay, so playing cards. From a standard deck of playing cards, we have to choose one king or one red card. Right? So how many ways we can do?
17.
16, sir. 16. 4 plus 12.
One red card.
14 plus 4.
Sir, 4 plus 12. 16.
Okay.
16.
Okay. So okay. So this is, if you call this T1, this tax is T2, right? Okay.
16.
So okay. So how many kings are there? 4 kings are there. So 4 ways we can choose it. 4 ways, right? And how many red cards are there?
28.
Okay. Let's analyze this. Okay. How many red cards are there? 26, right?
26, sir.
26.
28.
So
28.
we
28.
so if you follow the usual rule, okay. Keep silent. So if you follow the usual rule that if you do this T1 task and T2 task, M1, M2, M1 plus M2, then actually we are getting some extra number of ways, right? Why? Because since in the 4 kings, actually there are also 2 red cards. So we have to subtract that, right? So what will be the number of ways? And 2 are common. So whatever we choose, we subtract the common ones. So number of ways equal to 4 plus 26 minus 2 is equal to 28, right? Okay, so from these examples, we can state one more principle. This is called principle of multiplication, since we are multiplying every numbers. Okay.
Sir, fundamental of addition, sir.
Oh, this one is multiple. Sorry. This is the first one. And the second one is if we have to do one of the tasks, and there are n common tasks for all, then the number of ways
M1 plus
equal to what?
M1 plus M2 plus
M1 plus M2 plus plus
minus the common task.
Mk minus
The common task.
minus n common n, right? We have taken n,
Minus n.
right? Okay. So using that, we will do the same kind of one more example. Suppose we have to.
Excuse me, sir. In that one, sir, like you have the common task in each and every one of those ways.
No, maybe two
So it
of
will
them
be- No, sir. Then
do n distinct ways.
No, sir.
Huh,
Like
distinct
for
common
each-
ways.
For each, like M1, M2, they each one will contain the common task itself, right?
Yeah.
So it will be minus k minus 1 and
Okay.
then
No. This n means If suppose maybe 2 tags have the 2 common things, so you will count them 1. 3 tags have one common thing, you count them 1. Everything. So you common ones you
So we
subtract.
just put all the common.
I have just put all commons in n, right? So we'll do one example. Apply this rule. So same card things. A king or a queen we have to choose. First, a king or a queen. We have to choose from standard deck. Second, a king or a jack. Maybe. Yeah.
8.
Oh, same thing. Okay. So one black card.
28.
Oh, the previous one, right? Same thing. Uneven number card, uneven number card or a spade. And fifth one is a heart, a diamond or a cloth. So first one, how many ways we can do? 4 plus 4?
28, sir. Third one's 28.
First one, 4 plus 4 equal to, everyone knows how did you get that? And this one, 28, I don't have to analyze again. Yeah, I have to. Okay, so 28 ways, we have done already that. So, and this one,
28, sir.
how did you know?
Sir, 14
So this is
plus 20
tax
minus
1,
5.
this is tax 2. An even number of cards. So in a deck of cards, how many even number of cards are there?
5. 2, 4,
In a suite there are 5.
5.
And there are 4 suites.
20.
20.
20 plus 30.
Everyone, are you following everybody? So 20. So this is 20 way.
20 and spade is 13, sir.
Every there are 4 suites are there, right? So each has 2, 4, 6, 8, 10, right? So there are 4 suites. So how many will be there total? 20?
20 and 20.
Okay. Oh, you are taking. We are telling answer.
No, spade
We are analyzing this one only. Okay. How many ways we can? There are even number of numbers we can choose. Okay. 20 ways. And how many spades are there?
13.
13.
Minus 5.
13 minus 5.
So total how many ways we have to do? 20 plus 13 and how many commons? Because spades have 5 even also. Right. Minus 5. And n is 5 here. So this is
So it's 28.
how many?
33 minus 5.
28.
Yeah.
Okay. A heart, a diamond or a cloth?
It's 13.
Sorry? 13? Cube. Oh, what is this? A heart or sorry.
Yeah, 39.
I have to write or here. Yeah. A heart or a diamond or 39 because this is 13, 13, 13 and or. We have to do one tax only. So 13 plus 13 plus 13 is equal to 39, right? Okay. Good. Now, if we do an arrangements, suppose there are n objects, we have to arrange them differently. So, how many ways we can do? Suppose there are, so one example I am giving. Suppose there are 3 students in a school. There are 3 students. Suppose A, V, C. Yes? Students called A, B, C. And they have to be put in one of there are also in the school there are sports teams are there. So there are 3 sports teams. Suppose sports team. Suppose name 1, 2, 3. 3 teams are there, right? So we have to put in every team 1 student, right? So how many ways?
3 factorial.
6 ways.
3 factorial.
Okay. So how do you know 6 ways?
First one is 3.
So okay. So we have to choose. We have to put 1 student in each one. Okay. So if the team 1 choose 1 student, so how many options are there? 3 options are there, because initially we will start from team 1. So it has 3 options. Okay. So 3 ways. Either it can choose A or B or C. So 3 ways, right? Okay. And then the team 2 will choose. So how many options will they have?
2.
Because already team 1 already choose 1. So there 2 will be remain. 2 options. So 2. And the third one? 1. He has no option. Okay. So total 6. Now if we increase that A, B, C, D, suppose.
24.
So that will be 4. Right. So in that case, what will happen?
24.
I just bracket it. Okay. The previous one. This 4 into 3 into 2 into 1. So that will be 24. If we make one more, E, then 5,
120.
then we have to multiply 5. Right. So these ways of writing the numbers we call factorial. We give one number called factorial, because every time we have to write a long expression. So instead of that, we can choose one symbol for that, right? So if we have n is one integer, so positive integer, n minus 1 into n minus 2 into 3, 2, 1. Then we call this number n factorial, or in short it can be written as exclamation, right? So if we say 10 factorial means what? 10 factorial means 10 into 9 10 into 9 into 10 into 1, right? 15 factorial means 15 into 9. 100 factorial means 100 into this. You don't have to if you write just 100 factorial, it means 100 into 99 into 1. So in the short form you can write the big expression. So now, so here we see that if there are n objects, how many objects were there?
4.
In this case 4 objects. How many slots? 4 slots they have to be put, right? So we got how many arrangements?
24. 4 factorial.
That factorial number, right? So the same way, suppose there is I will okay, state that if n objects are to be put in n slots,
N factorial.
then the number of ways it can be one is
N factorial.
n factorial, right? Where n factorial equal to n into
N minus 1
n minus 1 into n minus 2 into 3 into 2 into 1, right? Okay, so using that one we can do one problem. Suppose there is one word dosa, you know. So using those alphabets, how many different words we can
4
make?
factorial.
24.
24.
24.
4 factorial.
We can arrange different way. No?
24.
How many? So there are n is equal to 4 letters total. How many alphabets? 4 alphabets. We can make do. We can make units. Okay.
Yeah.
Or we can, if we have a same kind of analysis, if we have 1, 2, 3, 4 slots, then the first can be done in how many ways? 4 ways. Second one 3 ways, 2 ways, 1 way, 4 factorial. Right. Okay. Now, if you have to do 3 letter words, we have to arrange or make 3 letter words. So how many ways we can? Out of this letter alphabets of dosa, we have to take 3 alphabets.
24.
How do you do?
4 into 3.
4 to 3 into 3.
Yes, sir. 24.
3 letter words. Okay. So there are how many slots? 3 slots.
First one.
So NP3.
So first one can be 4, 3 into 2. Okay. 24. Okay. If we make 2 letter words,
12.
12.
8.
12.
12, 2 letter words. So first one has how many options?
4 to 3. 4.
4. Because total we can choose D, O, S or A. There are 4 options. Like D, then we can choose O, S, A. So this is 3 types. So we, first we can take also O, then we take O, then here also D, S, A. S, if you take, then O, D, A. Then if you take A, then there are O, S, D. Then how many? 3 plus 3 plus 3 plus 3. 12 ways. Okay. So choosing out of, so what we will state one more principle. Out of n objects, n distinct objects, n distinct objects, out of n distinct objects, R objects can be chosen in N, P, R ways. N P R means n permutation. This means what we call this? N permutation R. N permutation R. Okay.
So you written NPN, so
NPR actually. Oh, my handwriting is not good. NPR. And what is this NPR?
N factorial by n minus 1 factorial.
Where NPR equal to n factorial by
N minus r factorial.
n minus r factorial. Right. Or how do you get this one actually, this number? Because while we are doing this problem, I think 2 letter words, right? 4 into 3, 2 letter words. So this is actually there are 4. We can do, there are 4 alphabets, and we have to choose, or we have to arrange 2. We have to arrange it. So how many ways we can do this? 4 factorial divided by 4 minus 2 factorial equal to 4 factorial means what? 4 into 2 into 1 divided by 2 factorial means 2 into 1, right? Equal to 12. Okay. This was actually about arrangements. Now we'll do one more things. So if we are going to one bicycle shop, and there are suppose we have to buy 3 bicycles. How many? 3. And there are suppose in the shop actually there are only 5 bicycles. A, B, C, D. 5 bicycles.
60 ways.
Okay, so we have to choose 3. Have to choose 3. So how many ways we can do?
60 ways. 60 ways.
It'll be 5 factorial
Five
by
factorial
5
by
minus 3
factorial.
factorial, which is 5 factorial by 2
By 2 factorial,
factorial,
which
which
is
is
60.
120 by 2, which is 60.
Yeah. So we actually we usually see that we can do it by n p r equal to 5 p 3 equal to 5 factorial by 3 factorial. Sorry, 2 factorial. This is equal to 60. But is it correct?
Yes, sir,
Yes,
it's
sir,
correct,
it's
sir.
correct,
Find 4 into
So
3.
provided the 5.
We are choosing.
Sir?
We are choosing 3 bicycles, right?
Yeah, I know.
So
No, if we take it, like, we solve that thing, we'll get 5 into 4 into 3. That's
okay,
what I told.
we will get 5 and 4 into 3.
Yeah.
Okay, but is that the correct number of ways we
So
can do
provided
this?
all the 5 bicycles are distinct.
Remember, here we are choosing 3 bicycles. Doesn't matter if suppose we are choosing B, D, E. Suppose first, so there are 5 bicycles. We have to first choose one, then second one, then third one. The first we choose B, then D, then E. But suppose there will be another way. We can choose D
Yeah, I know.
and E. There may be D, E,
So 5 C3s,
B.
not B3.
B. Okay. So and there may be also V, E, D. So 5 E, V,
10 ways.
D, and 6 E, B, E. Are these different or same
Or all same.
for us? Because we are anyway we have to choose 3 bicycles. Doesn't matter whether we first choose B, D, or and second we choose B. We have to choose 3 bicycles only.
10 ways.
But while we are doing these things are also coming into this, because this formula applies when
Arrangements.
for arrangements. If you consider these are different things, then you can use this one, right? If these are same, then we cannot use this one. So how many extra things do we have actually? 6.
R factorial.
6 things. So 6 extra, or that can be written 3 into 2 into 1, 3 into 2 into 1. Because if we choose 3 things, first we can choose this in how many ways? 3 ways.
5
First one I can choose in 3 ways. Second one can we choose 2 ways, and third one can 1 way. Because 3 cycles we have to choose. So for everything, suppose instead of BDE we will choose FBC. Also in that case also 6 extra things will come. Right?
5 C3s.
No. These are complete ones. We are choosing only 3. You can choose set up BDE or any 3 cycles you have to choose. No? Suppose I tell ABC you choose. So this combinations will also be good. A B C A C A B. So always we are calculating 6. So what will be? We have to divide
By 6. 5C3.
by 6 or what that?
3 factor.
How many ways we are choosing? That factorial. Because 6 was what? 3 into 2 into
20.
So how many ways now? How many? 10.
10 ways.
Okay. So got answer. Know how to use this. Where to use? This is not true now because now this is called NCR. And this is the formula is n factorial by n minus r factorial
Into R factor.
into divided by r factorial. This is so we can state one more statement. Sorry, this also. This what is actually important? This is not chosen. This is arrangement. Can be arranged. Arrangements, all those B, D, E, D, B, E, those things are different. But while we are choosing, those will be same. So one statement we can write that out of n object, if R are chosen, then the number of ways will be NCR, that is equal to n factorial divided by n minus r factorial r factorial. This is called n chosen or n chosen R or n combination R. There are permutation here, combination or n chosen R you can say. Okay. What is the time now? Okay, these are all. So you have now break for 10 minutes? Or?
No, sir. Wait.
Okay, we'll do problem.
Yes, sir. Yes,
Okay,
sir.
good. Now these were all we analyzed where every objects were distinct. Now we'll do problems on repeated objects. Some identical objects are there. Then how will we do this? Suppose there is one letter and then there is one word called success. Okay, so using the alphabets of or letters of this word, we have to do arrangements of 7 letter words. So how many ways we can do it?
To make how many letter words?
How many? 7 letter words can we form?
Yes, sir. 420. Sir. 420.
Okay, so
Into 2 factor.
there are how many letters? 1, 2, 3, 4, 5, 6, 7. If there suppose if they are distinct, then how many ways we previously we did one problem. Suppose A, B, C are there, so this can be arranged in how many ways? 3 factorial ways. Here all were distinct, but here some of them are identical, right? So if all of them are distinct, then we can do it in 7 factorial ways, right? But some of them, like S, there are S is equal to, number of S is equal to 3, and C equal to 2, U is equal to 1, E is equal to 1. So distinct ones we don't worry about. So these S things, suppose so there are 3 S. So how many extra things we are, or extra ways we are?
3 factorial into 2 factorial.
Because these 3, suppose these were different S1, S2, S3. These are this can be arranged in how many ways?
3 factorial.
3 factorial. 3. Suppose S1, S2, S3, then S1, S3, S2, then S2, S1, S3, S2, S3, S1, S3, S1, S2, S3, S2, S1. But here actually these S are same, right? So you cannot distinguish which S is this or that. And also this C things also can be.
2 factorial.
If you take C1, C2, then this will be C1, C2 or C2, C1 is written.
Sure, first and second or same.
So this will be done in 2 factorial ways. This can be done in 3 factorial ways because 3 things is there, right? So are everybody following or not?
Yes, sir.
So we have to divide this 2 things here. 3 factorial into 2 factorial. So number of ways will be like this. How? 420. Everybody got this? Okay. Okay. So using this one also we can do one more problem. Suppose there are 2. Okay. There are 2 boys and 2 girls. They have to be seated. 2 means on a bench so that girls are together. No. Girls are together and boys are together. So how many ways we can do this?
8 ways. 8 ways. 8 ways.
2 ways.
8. 2. For every 2 of them, they can make a change. For every 2 of them, they can make a change. What? 8 ways.
How do you get this number? So we have 2 boys, right? Suppose I will call them B1 and B2. And there are 2 girls also. Suppose we call G1 and G2. There one bench will be there, like this one. Okay. So since we have to make arrangements so that both girls will be together and both boys will be together. So first is we can do that's V1, V2, G2. The boys can shift this side and that. Or there is one more way also. You can G1, G2, V1, V2.
Sir, or
Okay.
B2, B1 themselves. B1 they can see
So this can be done in two ways. And here, this V1, V2 can be also
interchange.
changed. And
G1,
G1, G2 also can
So
be.
eight ways.
So here it will, I can do also two ways, right?
Yeah.
And here also two ways.
2 ways. So 8 ways.
Are you following everybody? Or?
Yes, sir.
So this will be 2 into 2 is equal to 8 ways. Okay. Is that everybody?
Yes, sir.
Okay. Okay, we'll do one circular problem, then we can do the problem set. Okay. Now we'll have to arrange the people in a circle. Previously we are doing we are dealing with the linear permutation combination. Now we will do with circular ones. Suppose there is a circular arrangement and 4 people will circular kind of thing, and there are 4 seats. Here one seat, here one seat, here one seat, and 4 people will be seated there. Right? There are 4 people: C1, C2, C3, C4. C4. So how many ways we can?
6 ways. 6 ways. 3 factorial. 6.
How many ways? We can
6
do?
ways. 6 ways.
How do we know?
So n minus 1.
N minus one factor.
Because
Why n minus 1? Why? Because previously we are doing.
You have to fix.
sir, we have fixed
Previously we are doing n factorial. If there are
Sir.
n objects, then we can arrange them in n factorial.
So you have to fix some objects are, and then you have to interchange the other n minus
Sir,
one
there
objects.
will be 2 objects which
So
are
then
be
you-
like same. That is
Yeah.
clockwise.
Okay. So, as previously as we have studied, so we should say 4 factorial ways we can arrange these things. But is this correct? Suppose let us check whether this is correct or not. Suppose in take one arrangement here C1, C2, C3, C4. So if you just rotate these things, just make it C4, C1, then C2, C3, and this will be C3, C4, this is C1, this is C2. So this will be this is C2, this is C2, C3, C3, C4, this is C1. Okay. So if you see this arrangement, if you consider people who is sitting to left to who is sitting to right to whose, then so if you observe, C1 is always sitting to the
Top.
to the what?
Left of
Left
Right of-
to the right of C2. Right.
Right of
C1 is sitting
right
right of C2. Right. Here C1 is sitting
right of C2.
right of C2.
Sir,
Left.
left of C2.
C1 means is sitting like this, is sitting like this. So right always, na? C1, C2. Right. So here also C1 is sitting
Right of C2.
Right of C2.
right of C2.
Sir, left, sir.
Left.
It's
Left,
left, sir. But for
Okay, okay.
C1, C2 is right.
Sir,
Sorry,
C2 is
C1
Okay,
is
okay.
C1 is facing in this.
Oh, that way. So C1.
Yeah, it's left.
So C1 is sitting like this. So C2
Yeah.
is like this. So this is
C4 is right.
left. So left. Yeah. So C1 is always left to right to C2. C1 is sorry. C1 is right to C2. No?
For C2,
So
C1 is the
C1
right.
is seated at the right of C2.
For
C2 is sitting like this.
Okay.
And
At the
there
right
C1
And
is
the
sitting
right
like
is
this.
C1 is there.
Ah,
Yeah, exactly. For C2, C1 is at the right.
Yeah.
For
For
C1,
C2.
C2 is at the left.
Right. So for C2, C1 is right. So here also for C2, C1 is right. For here C2, for C2, C1 is right. Here also right. So if you consider other things also, C4 also. C4 is sitting
Left of C1.
Right
Left.
of C1.
Right of C1.
like that. Right. What? Right of C1. Yeah. Here also
Right of
Right of C1.
right also. Here
Right.
Right of
here right also. So actually all these arrangements are same. With respect, if you consider who is sitting with respect to what. So we are counting 4 extra ways actually. So initially it was thinking that 4 factorial eligibility, but 4 ways are same.
By 4.
So by 4 equal to 3 factorial equal to 6 ways. So why is it happening here in circular case, not in the linear case? Because in the linear case, what we are arranging things are in a line, and there are 2 endpoints. Here
Continuous.
there is no
Infinity.
endpoints. You can choose this one endpoint. You can choose this one endpoint, or this one, or this one, or this one. There is no endpoint. You can choose any one. So that's why it is coming extra. So we can give one statement. In a circular, permutation, you can choose n objects. In a circular permutation, we can arrange n objects in n minus 1 factorial ways. Suppose if we take 5 boys, then it will be how many? 5. Suppose A, B, C, D. A, B, C, D, E. 24. 5 minus 1 factorial, that is 4. 4 factorial, that is 24. Okay. Okay. Now using all these principles, we can do one problem set. So I will give just fast. One fast. Did everybody got it? Two. This one. Everybody got? Okay. So we'll do problems by one.
Do it in the worksheet itself, sir.
Sorry? Sorry?
Write the answer in the worksheet.
Have you given?
Can we write the answer in the worksheet itself?
No. I will do this one by one. Okay, one of you can come and So that everybody will know this. Okay. So, what is the first question is, how many straight lines can be found by 8 points of which 3 are collinear? So,
3360.
who can do?
6720.
3360 is
6720 is.
by 2 factorial.
Can you explain? Come to what? Can you explain? How did you got this?
Is it
How did
right?
you get this? Oh, you can come and explain.
Is it right?
6720.
3360.
How did you get this number? Step by step you can explain.
First one. Sir,
Mhm.
we'll do the next one, sir.
Okay. No, we can do one by one. If you can do it, if some problems were left over, then you can do it later on. We'll do for all years. Okay. So, can you come and explain it in the board?
So I have to explain also.
Yeah. How did you get these numbers?
For making a straight line, we need 2 points. So if all the points are not collinear, 8 factorial by 2 factorial lines will be formed.
E factorial by 2 factorial lines. So, here there are 8 points. For making one line, how many points do we need to make one line?
2 points. Oh, 8p2.
2 lines we need. So whether we choose 1, 2 or 2, 1 doesn't matter. We will have one straight line, right? So it will be permutation or combination. So out of 8 points, we have to choose 2 points, right? Combination or permutation? Because this, suppose this is 1, 2, 1. These 2, we are not giving any distinct names to these things. For us, this and this are same. This is one line, this is also one line. So both are same. So we are choosing or arranging?
Choosing.
Choosing means both are same. Arrange means this is different.
So both are same.
So here we are telling from 8 points how many lines we can draw. So what we are doing? Choosing or arranging?
Choosing, sir. Choosing.
Choosing, yeah. Because for choose actually these 2 lines, whether you do it this way or this way, both are same to us, because we are concerned with lines only, not line of what is that line, A 1 2 AB or BA. We are not talking about that. If that is a line, we are done. So what we are doing? Arranging or choosing?
Choosing.
Choosing. Everybody clear or confused? Clear? Because both are same for us. We are concerned with lines only, not line names or something. We are not making difference between these 2. Okay. So out of 8 points, we have to choose how many?
2 points.
Choose
2 points.
2 points, right? In how many ways we can do it?
8c2.
So which one we can do? Which principle we can use? This principle. Out of n objects, if r are chosen. Out of 8 points, if 2 are chosen. So which one we will use? This one. There, what is the statement here? Out of n distinct objects, r objects can be arranged. These 2 words are important. Okay. The difference between permutation and combination is the word chosen and arranged. Or that is ordered one. This is not here. Here the order is not matter. There the order is matter. That means 1, 2 and 2, 1 are they're different there, but here order is not matter, they are same. Okay. So from 8 points, in how many ways we can choose 2 points to make it 8?
C2.
C2, right. What is this? 8 C2? This 8 factorial by
6 factorial into 2 factorial.
n minus r, 8 minus 2, 6 factorial into divided by
28.
2 factorial, right. That is equal to how many?
28.
28. Is come correctly? 7, 8, yeah, 1, 2, 7 into 8, 1 into 2 into 1 into 2, equal to 28, right? So how many, yeah, what is the question?
So
How many
provided
straight
the-
lines can be found by 8 points of which 3 are common?
So we have to.
So this is the final answer, or we have to add or
We have
subtract
to
something?
subtract.
Why? Because there are 3 collinear points also. Out of these 8 points, when it will be correct? If all the 8 points are distinct, not in a straight line, not in a, not they are not collinear.
So 26 ways.
So since there are 3 collinear ones, suppose this point, these 3 points are collinear. So we can draw only one line. Because if we draw this one, 1, 2, 3, 1, 2, 1, 3. So 1, 3, 1, 2, 2, 3 are same line, right? So
minus 3 plus 1.
so there are 3. So how many lines actually we can count out of 3 points?
2.
3, there are 3 points, na? 3 collinear points. Out of that 3 collinear points, we can draw 3 C2 lines actually. That are extra things here coming. If that, so that is equal to
3.
3.
So 3, sir.
Okay, okay, 3. So we have to here for question number 1, we have to subtract that.
Subtract 3 and add 1.
3 C2. So total it will become 8 C2 minus
3 C2 plus 1.
C2 plus
1.
1, because all 3 can make one line. We will consider them one line, right? We will subtract first, then actually these things are 1, so we have to add 1. Everybody understood? Okay. So this is for a particular case. If we generalize this one, if there are n points and R are collinear, then how many lines we can draw? Okay, you can see. Thank you. Then how many lines we can draw? The same thing. NCR, and since there are R collinear ones. Sorry, minus RC. Sorry. N points are there, out of which R are collinear, and N is there. So how many lines we can draw? In the previous case, what was that? 8 C2 minus 3 C2.
NC2 minus RC2 plus 1.
Here NC2 minus NCR minus RC2
2 plus 1.
plus 1. Plus 1. So this is the general formula. If we have n points, out of which R are collinear, then we can draw NCR minus RC2 plus 1 number of lines. Oh, sorry. Okay. Oh, that you were telling me. Thank you. NC2 minus RC2 plus 1. Okay. So, yeah. Okay, general treatment you can write this one. Out of n points, If R are collinear, then we can make NC2 minus RC2 plus 1 number of lines. Okay. So for problem 1, any particular problem you can do, na? So instead of 8 points, 10 points, 15 points, 100 points, and instead of 3, any number you can give. So this is the general formula you can use. So for this you can out of n points if R are collinear,
The number of lines formed are NC2 and RC2.
then the number of lines, number of straight lines, straight lines can be found equal to NC2 minus RC2 plus 1. Okay. Now the same thing we can do. How many triangles can be formed by 8 points of which 3 are collinear?
55. 55.
Now we have to make for question number 2. For question number 2, we have to make what? Triangles now, right? So we need 3 points to make a one triangle. Since there are 8 points, so if not no points are collinear, then we can make 8 3 triangles, right? If all are distinct or they are not collinear. But if R are collinear, then we have to minus the extra ones. Right? How many?
3C3.
R? Achha, for this particular problem.
Yeah,
3C3.
3 C3. So why here 3? Why there 2? Everybody understand? This is our straight line.
Number of lines, number of points required for the completion of
Okay. Yeah. So this is for general. So general statement what we can make?
Okay.
So general statement what we can make? Out of n points, if R are collinear, then the number of triangles can be
formed is NC3 minus RC.
Okay. Everybody understood? Or no?
Yes, sir.
Thank you. Very good. So out of n points, if R are collinear, then the number of triangles can be formed equal to n C3 minus R C3. Okay. I can erase this one. Now similar kind of forgot to mention one. Suppose there is one n-sided polygon. N-sided polygon. So how many diagonals will be there?
N into n minus 3 by 2.
N-sided.
N into n minus 3 by 2.
N into
N minus 3 by 2.
3 by 2. How did you get this?
Sir, we can derive it, sir.
Okay. Yeah, come.
Sir, once again, sir.
No, sir, we learned it as a formula.
Sir, no, sir.
Like
That's a
formula. How did he
derivation.
get
I
this?
don't know. We
That's-
learned it in
we
politics. That's it, I
are not doing here. We are not writing formulas here. We are
Right, sir, once again.
how do we get this? So how many diagonals are there in a n-sided polygon. So, can you come?
One second, sir. One second, sir.
But I did the third one in the book.
Okay. Yes, first we'll do this general thing, then we can do it. Okay, how I can do it also. So, how many for n-sided polygon, how many vertices are there? How many points are there? Vertex points are there?
N points.
N points? Yes.
Yes. And
N
inside.
regular thing. So, n points are there. So, out of these n points, we have to make straight lines, right? There are sides and also diagonals both. So, how many straight lines we can? How many straight lines we can make? From n distinct points. These are n distinct points, right? So, how many straight lines we can form? N?
Sir.
N distinct points. Not we are not concerning the side. For a n-sided polygon, there are n sides and there are some diagonals also, right? Out of n points,
N minus 1 C2, sir.
or using n points, we can draw NC2 straight lines, na? And all these lines include both sides and diagonals, right? And how many out of if you exclude sides, then others will be what? Diagonals, right? Because this will take this one. 1, 2, 3. So we have this is a hexagon. How many sides are there? 6 hexagon. 6. So 6 sides.
9 diagonals.
And how many diagonals?
9 diagonals.
So we can draw this to this. So this also we can do this. So this also, right? We can do this also. So how many are there?
So another one.
So another one, so yeah, then
Oh, this one.
and one more.
Hmm?
This way. Yeah. No, this way.
No, from that.
Yes, sir.
That
From that to the above, right?
Above one.
Above,
Yeah.
right? Which one?
Yes.
Exactly.
This is this
So
one.
That was like
so cut the hexagon.
Oh, this one.
Exactly.
Oh, fast.
So one
So
more.
one more.
One more, so like that.
sir, top right to bottom.
Top.
Yeah.
This
Yeah,
one.
exactly.
So double.
Yes, sir. Now it's
So how many are there?
9.
Okay, so total, if you count total number of lines, so how will be there? How many will be there? 6
9 plus 6.
C2, right? Total, if you include both sides and diagonals, then there will be 6 C2 is equal to how much? This is 5, 6 into 4, 6 into 5 into 2, 1, 2, 2. So this is 15. If you are getting 15, okay. So out of this 15 straight lines, how many are sides of this polygon?
And 6.
6 are sides of this polygon. And others are diagonals.
So minus 6.
So number of diagonals.
C2 minus 1.
Number of diagonals equal to 15 minus 6 equal to 9, right? So for this general case also, what we can get out of this n points, we can draw NC2 lines, right? And we So to get the number of diagonals, we have to do what? Minus n,
Yeah,
right?
just n and n minus 3.
So this is number of diagonals. Equal to NC2 minus n. So what is this NC2? NC2 means n
n into n minus 1 by 2.
n factorial divided by minus 2 factorial into 2 factorial minus n, right? So up to n minus 2 factorial it will cancel, right?
n into
n into n minus
So
1 by 2.
n into n minus 1 divided by 2 minus n.
n square minus 3.
If you simplify, then you will get
n into n minus 3 by n. By 2.
n square minus
3n
3n divided by
2.
2 equal to
n
n into n minus 3 by 2. Right. If you solve this, you will get this one. Okay. So you can tell if you are given one n-sided polygon, then what will be the number of diagonals? You can tell easily using this one. Or suppose you don't remember this formula, just you can derive it for yourself, right? Just use the general principle, you can for yourself. Just remember this logic only. You may not remember this n into n minus 3 by 2. It's good if you remember this one, but it's better to. Okay. So how many? Okay. Okay. Number 3. So I can erase these things. No.
Yeah.
Everybody noted down? Or? How much time do we have? 11:15.
10.
Yes. 10? 11:10. Okay. So we have still more time. Okay. So we can do the third one. How many committees of 5 students can be selected from a class of 25? Is this problem?
53130.
So everybody got this? Or? How many of you got this? Number 3. Question number 3. So how many committees of 5 students can be selected from a class of 25? There are 25 students, right? We have to choose how many?
5. 25
Five.
plus 5.
To choose. Choose means what? Which thing we
25
will?
25.
Yes, sir. So what number you will get? This one? C5. Okay, the multiplication thing you can do later, but if you got this one, then it's okay also. The multiplication thing you can do always, no?
So can't use calculator.
Calculator you can also use. Just we want to know the correct way for doing things, whether we are doing correctly or not. Now, so problem 3 for everybody is finished. So now we will go to problem number 4. How many 10-letter patterns can be found from the letters of the word basketball?
So 428600.
If you ask, then
4536.
okay, you know.
45360. 4280.
Okay. How many? words can be formed using this. Okay. You don't have to calculate the numbers, just in the factorial form also. What will be n factorial divided by how many b's are there? Achha, how many a's are 2 and l 2, others are 1. This number of 2. Then number 5. You have some problem? Are you following this one? Okay, the multiplication thing you can do later on. 5 box contains 12 black and 8 green marbles. How many ways can 3 black and 2 green marbles be chosen?
2, 4, 6, 4, 0.
So there are. Can anybody come and explain this problem here? Okay, come. Yeah, come. Yeah, you can. No, you can explain it to them. Number 5.
So there are 12 black and 8 green marbles. How many ways can 3 black and 2 green marbles be chosen? Should be 12 C3 plus.
Right. What are given and what you have to choose and how many ways you can choose. Just you don't have to write everything, but just symbolically. 12B means black. We can do more problems. Tell them, explain them also.
So 3 black and 2 green marbles should be chosen. So we should choose 12 C3 and 8 C3. Therefore, this is 12 C3 plus 8.
Yeah.
This is 12 into.
That is in plus or into this one.
Sir, multiplication.
How many ways? 3 black and 2 green. Why? Because both packs we have to. Both packs we have to do. If or then we will. So which one we should do? This one or that? Which one? Multiplication we should do. We are doing all tags. Na? We are choosing 3 blacks and 2 greens. So both tags are we are doing. So we have to use this one. If one of them, then use this one. Okay. You got the number? Okay, right there. I have also answer, I can check whether you are telling correctly or not. So which number? This number 5th. So what did you get? How? Okay. You have to multiply both. So everybody got this? Okay. So now problem 6. Who can do this? 8 students on a student council are assigned 8 seats around a U-shaped table. How many different ways can be students be assigned seats at the table? number 8. Okay. We will do this. Right? Come. Okay, you can explain this.
No, sir, I don't know.
You can analyze the problems and so that you can do also. Come, I will help you. Okay, I will help you also. Come.
Not me. So someone else, so please.
Oh, we want to come? No, you come, I will help you.
No, sir, I don't know.
No,
No,
I will
do
just.
it once and I'll come.
Okay.
So, can
Okay, yeah, come.
I have a question, sir.
Yeah. What is given and what you have to
How
do.
many 7-digit telephone numbers can be formed? The first digit
No,
cannot be
this
0
this
or
is 6.
61.
6.
8 students on a student council are assigned 8 seats around U-shaped table. How many different ways can the students be assigned seats at the table? A. B. How many ways can the president and vice president be selected?
Yeah, right there. What is given and what you have to do. Yeah. Very well. In the short form, right. Here it's this important. U-shaped. U-shaped means
That is also linear, sir.
U-shaped means linear or circular.
It's a linear, sir.
Linear only, sir. It's just given to confuse us.
Yeah. U-shaped means in this way they will sit now. So it has a 1 and 2 endpoints. Then, but in circular thing there is no endpoints. If there are endpoints, then it will be a linear combination sequence.
That's what I'm doing.
You don't have to multiply this thing.
You need
Just-
to, right?
Yeah.
Okay, yeah.
So that we can finish many
Yeah.
Okay. And part B also there, na? So what is part B? How many ways? Yeah, you can. So what is the question?
How many
How many ways
presidents?
can a president vice president be selected from the 8 students?
There are 8 students. You have to choose 1 president and 1 vice president.
Yeah, 2 people.
Yeah, 2 people you have to choose. Hmm?
Sir, excuse me, sir.
Okay.
Sir, in 13th question, is it 16 factorial?
Yeah. Hmm?
LP just 8 choose 2, right? For selecting vice president.
Okay, 8 seat means what?
You're choosing 2 students from 8.
2 students from 8 students. Okay, then?
Like into 2 then. They can, one can be vice president, one can be president,
Yeah.
other can be.
First you will choose 2 students,
Yeah.
then 2 of the, 1 may be vice president,
It
1
can be
president.
swapped.
So 2 ways they can, it can be.
56.
Okay, one extra thing I am adding here. Suppose 3 president, vice president, and 1 secretary also you have to choose, right? So how many
18.
different?
8 is the lead.
8?
3.
Hey, you come from me. Finish the problem. One extra thing also. So we have to choose.
8C3 into C.
Yeah, it's okay. We can draw this one, this particular. Yeah. So C, you can see. So now you have to choose how many?
3.
C3, because 3 people, president, vice president, secretary, and
C3 into 6.
why 6?
3 factors.
So because 3 among those 3 can be arranged in 3 factorial ways. Na? One vice president, secretary, then and the other. I am just checking whether we are multiplying 3 or 3 factorial.
3 factors.
Okay. Correct. Okay, we will get to know that. Thank you. Okay. Then we'll do one more problem. This 8. How many 7-digit telephone numbers can be formed if the first digit cannot be 0 or 1? Question number 8. So we can do. Come. Okay, come. Okay, I will help you. Come. Question number 8. Come. Others also help you. Come. So that you will comfort. If you come here, then you do the problems, then you will feel comfort. Come. Yeah, come. You will just. No, here I will help you. Just from beginning we will analyze the problem. The process it will be done. Okay, come. First, do the question for them.
How many 7-digit telephone numbers can be formed if the first digit cannot be 0 or 1?
So, yeah. So we have to, what is the task? We have to form 7-digit numbers, right? So for 7-digit numbers, we can place unit place, 10 place, right?
So
In
it
that
can
way.
be repeated, right?
Yeah, it can be repeated
Yeah.
because it is not mentioned anything. Right? So 7-digit number we have to make. Na?
So it
we
can also be
write
like
unit-
so it can also be like 7 2s or something like that.
Yeah. Unit place, 10th place, 100th place. Remember, write this up to 7th place. Or first place, second place, third place you can. First, second, third, fourth, 5, 6, 7. 7-digit number we have to fill up these places only.
Yeah.
So, what we will have to do? How many 7-digit telephone numbers can be found if the first digit cannot be 0 or 1? So, this will be the first digit. Na? Okay.
Yeah, so it'll be
It
7.
cannot be 0 or 1.
So
So,
it'll be 2, 3, 4.
how many
5,
ways
6,
we can?
8.
8.
8. Yeah. 8. So, this can be filled up in 8 ways. Right.
Next one can be that.
Next one can be? Other things can be 10. Right. So this number of ways is very simple. Thank you. Now we can do the 10th one. 10. How many different 5-digit street addresses can be can have the digits 4, 7, 3, 4 and 8?
5 factors. 120.
You can come.
No, 5 or 5.
Oh, one of you.
So 5 or 5.
Okay, please you come. Please come. Come. Okay. You come. So number 10. I will help you. Okay. I will help you if you just come. Come. It's very easy. Okay, you can do this way. The same way we can do. Come. You want to try?
So is repetition
Is
allowed?
repetition allowed? Or you should use all the digits or?
This all what did it say? How many different 5 digit street addresses can have the digits 4, 7, 3, 4 and 8?
So
Four
it can
can
be
be.
5, 5, 5, 5.
Yeah.
Like that. Can it?
So if it is like that, then the question is wrong, sir.
Hmm?
It
Then
will
you
be
then 5 or 5.
5 or 5 by 2, which will be which won't be real number. Let's see, sorry.
There are how many digits are there? 4, 7, 3, 4, 8, right? So how many different ways you can arrange
All
this
the
one?
digits have to be used.
All digits you have to use,
4
right?
is repeating.
4 is repeating.
So
So
five
which
factorial
formula?
by two.
Which formula do we have that?
Factorial by 2 factorial.
Which is
Yeah.
60.
Sir,
Hmm?
but,
Yeah.
sir, but that means that they can't, no repetition is allowed.
No, this no, right. This force will use, but suppose we are
So he's
using this.
asking something like 8, 8, 8, 8.
Suppose this is 4 number 1 and this is 4 number 1, this is 4 number 2, right?
So no, sir, he's asking something like 7, 7, 7, 7, 7.
Can it be a number?
Yeah. No, hear me. You have to use all these digits only. That's why we have it is given.
Yes, sir. 60 ways.
So how many ways you can do?
60 ways.
How did you get this number? So there are how many numbers? 5. So all 5 we have to use. We have to use.
So 5 factorial.
So how many ways we can arrange? 5 factorial.
Five
But
factorial.
there are
By
2 common. So what we have to do?
By 2.
By 2 factorial. It's like this basketball things we have done previously. It was much difficult. Or same similar problem. Okay, 11. One.
Sir,
Some last bench student should come. Yeah, come. Come. I will help you also. Come. Yeah. 11. Okay. Come. I will help you. If you you will get comfort doing this problem. You come here. You come here. Come. You want? Okay. Come. I will help you. Come. First read the question. Okay.
3 hardcover books and 5 paper bags are placed on a shelf. How many ways can the books be arranged if all the hardcover books must be together and all the paper bags must be together?
So what are given? Like this. How many hardcover books are there?
5 paper bags and
3 hardcovers.
so these can be arranged in 5 factorial ways.
Okay.
These should be arranged in 3 factorial ways.
Okay.
So they can be interchanged.
Okay. Oh. So you have to arrange this thing in the self. Okay. So you have 5 paper bag and 3 hard covers. Okay. So the two these things will be arranged in 5 factorial ways. This thing in 3 factorial, and this they can be interchanged. At the self is like this. So first we can put this 5, 1, 2, 3, 4, 5 paper bags. Then we can put this hardcover waves, 1, 2, 3. Or we can do also above, we can interchange also. Okay. 2 ways, and among them also we can arrange the 5 factorial ways. Here also 3 factorial ways. Okay. So time is already over. Thank you. Got this? Everybody got this number? Okay, so other problems you can do at your home, and in the next class we can discuss these things and some extra things also. Okay. Thank you. So other problems try at home or